Welcome to Grade 12 Math, Algebra Review Complete course. Today, we're going to talk about number relationships. Now, if you are not watching from a mobile device, there is a mobile app for this. It contains quizzes and as well as other study materials for you to study algebra. So if you're interested, you could check out our link in the video description below. In my opinion, it is very helpful and it would indeed increase your effectiveness in studying for grade 12 math. The app is for both iPhone and Android. So if you have a mobile phone that is either an iPhone or an Android, check it out. It's free. Before we get on to looking at number relationships, let's look at a tool that for visualizing the number system. This is called the number line, and the number line is good for you to mark where are the numbers, the relationship between numbers, and it's very good when you are solving problems in algebra, especially ones that has inequalities or greater than or less than associations. So as you can see here, a number line consists of a line and markings of numbers ranging from whatever that the range that you want to choose for your problem. So each number line has a different scale and a different range. But the purpose of the number line is for you to mark where you are on the problem and what is the relationship with regards to other numbers. And we are going to look at that more in detail in later slides. So what can the number line use for? Well, it is for, as I said earlier, visualizing relationships between numbers. And here we can see an example. Like, let's say you have two variables, and which is in this case x and y, and we're given the relationship of which x is less than y, or y is greater than x. So on the number line, what it would look like is x would be on the left hand side of y, because on the number line it is usually given that in the middle is 0 or any other number for relationship purposes, and that you on the left hand side is always the lesser value than the right hand side, which is of a bigger value. So now let's look at the other scenario. What if x is greater than y? So now in this case, then x would be on the right hand side of y. Okay, so now what if I don't want both of the variables that are on the number line? I just want to have to show the relationship of y and x by what can y be in terms of x. So like, let's say in the example below, what if y can be less or equal to x, what would the number line be? Well, in this case, you cannot see the y in the number line. So any number or anything that's represented here would be a value of y with regards to what x is. So with If y can be x, then we would mark x with a solid circle, as you can see in the number line below. If y cannot be x, then you would draw a circle and you wouldn't color in to the circle. So if, like, let's say if y is smaller than x, and if you want to just draw the relationship of x, you would just circle x but not color in. Now for greater and less than, it will be represented by a line or a colored line with an arrow, as you can see right here. So if y is less than x, it means that y can be anything that's less than what x is. So if x is -3, y can be -4, -5, or minus infinity. So in this case, we don't know. That's why we put a line and an arrow to the left-hand side of x to show that y can be of any value that is smaller than x. And the solid colored in circle means that it can also be x at the same time. So what happens if we want to display a range of values that a variable such as x can be, given actually a defined range for x? So in this example, like, let's say we're given the range of a and b, of which x can be in, right? So we're given the formula x can be greater or equal to a, or it can also be lesser or equal to b, where a and b are the lower and upper ranges, and x is the variable of which it is defined in the limits above. So now how can we draw this number line? So x can be visualized as in the number line, where you put a and b on the number line, and then you would highlight or draw another line or whatever that you can to display on the line where x will be covered in the ranges of a and b, as shown in the number line below. Now in this case, as we have told earlier about equal to, so if x can be equal to a and x can be equal to b, we would put a solid circle in the areas where a and b are, in which it is shown in the number line below. So now you may question, what would it look like with where the situation is x is within the range of a and b, but x cannot be a, nor x can be b either. Well, as I would say earlier, for if x can be a and x can be b, we would have a solid filled-in circle. But if x cannot be a, nor x can be b either, we would just not color in the circle, as you can see in the number line in this slide. Okay, so in math, we got something called absolute values. So absolute values are used in situations where we are only interested in the value, and we don't care about whether it is a negative or a positive number. This can be displayed as a value with two vertical lines, one on the right and one on the left hand side of the value. So one of the examples that absolute values is used is distances. So let's say whether you calculate, let's say if you're trying to cover what is the distance between a point in -3 and a point in 3, it doesn't matter where if you calculate -3 -3 or 3 minus -3, the answer that you only want is 6 because you only want the distance. So therefore, in this case, an absolute value is used. So absolute values are shown with two vertical lines surrounding a number. So for example, if you have two vertical bar lines surrounding -4, your answer would be equal to 4, which is the same as if you have an absolute value of 4, which is also equal to 4. So some of the properties of absolute values are that if an absolute value of a negative number is an absolute value of the positive number, given that the value is of the same, right? Another thing is the absolute value of a product, such as x times y, would be equivalent to the absolute value of x times the absolute value of y. Same as for division, where let's say you have two numbers, a divided by b. The absolute value of this division would equal to the absolute value of a divided by the absolute value of b. Another thing I want to talk about is midpoints. So what are midpoints? Well, let's say if you're given a range and you want to find the middle value of it, then you would need to find the midpoint of that particular range. So let's say if you have z is the midpoint of numbers x and y, the midpoint z can be calculated as z equals to x plus y over 2. So let's look at an example, right? Let's say on the number line, you want to find the midpoint of where the lower limit is -8 and the upper limit is 2. So what is the midpoint or the middle of this range? So the midpoint is, if you follow the formula z equals x plus y over 2, you would have -8 plus 2 in brackets and then divided by 2, which is equal to -6 divided by 2, which is equal to -3. The last thing that I want to touch on in this lecture is intervals. So let's look at finite intervals first. So first, what are intervals? Well, intervals is where it would tell you what is the range of a particular variable is. It is very helpful, and it is a convention that we use in math. So let's look at these 4 cases. So with the circular bracket, the ones that are not squared, means that the range does not cover those values, which in this case is a and b, but it covers all of the values in between. So if we look at the convention, it equals to x and the vertical bar, which means x is can be represented on the range of a, where x can be greater than a but not equal to, and x is lesser than b but not equal to b. Now, for any of the square brackets, they're next to those numbers, either a or b. It means that the variable can be equal to that number, So in this case, if you can see on the examples 2, 3, and 4, you could see that it is greater or equal to or less than or equal to, given where the square brackets are on the convention on those finite intervals. So on the last examples where the square bracket is on next to both a and b, there's no open brackets that you've seen, the relationship is x can be greater or less than a, or x can be lesser or equal to b. Now the last one we touch base is called the finite intervals, where a and b is of a particular number. We also have something called the infinite intervals, where we don't have a range. So like, let's see if you see here, where let's say you have the range is a and then infinity, you would just have, for the first example, let's just say, it would be just x greater than a, because we don't have a upper limit for x, and x is an infinity. It can be just lesser than infinity in this sense. So that is why this is considered an infinite interval. So that is the end of this lecture. Thank you for watching. If you are interested in more of our videos, please visit our YouTube channel. The name of the YouTube channel is Mike Tutor, and I have a lot of learning videos that covers the grade 12 subjects. We also have a link in our YouTube video descriptions. That link would lead you to our site, where you would find some quizzes, other study materials pertaining to this course, as well as a link to our free mobile app for your iPhone and Android, where you can view all of the study materials and quizzes from your mobile device. And if you enjoy looking at our videos, and if you want to support us, please like our videos, share it with your friends, share it on Facebook, Twitter, as well as subscribe to our channel. I hope that you find this information helpful. Have a great day.